Hi, this video series is going to be on how I made this CNC. I designed it from scratch with Fusion 360, and there are a few things different than most builds. My Xaxis is recessed back quite a bit more than normal, and my Xaxis I have two rails. It might not seem too odd, but I have an extra one below, or you might say I've got two below and an extra one in front. But a three rail system, so that's odd. I like it for rigidity purposes. And let's see, the Y-axis not too abnormal, except that none of my motors, none of my steppers are sticking out from the machine. Sometimes they do that. My electronics, made this box with hinges, and this closes up, of course. It's open up just so you can see it right now. But I've got an intake fan with a filter and an exhaust fan on the other side that helps pull the air out, and I feel like it makes pretty good difference. I've got the really cheap breakout board. I like it. This is 60 volt system. The drivers are capable of taking 80 volts, 8 amps, but I'm pushing 60 volts, 4 or 5 amps. My steppers can only take 5 amps. Of course, you got a VFD. So that's the basic system. I use Mach 3 to control it. It's a wooden table. I'm surprisingly happy with the wooden table, except for these pieces here. I used what I had on hand, and I used these because they were nice and flat and parallel, consistent. But the material on the surface is, I think there's like glass in it or something. It's really hard on your cutting tools, your drills and whatnot. So I would never use that again. The rest of it is bamboo. This is bamboo flooring. It's not too bad. This is a bamboo cutting board from the dollar store. This is some sort of epoxy fiber phenolic stuff. I don't know what it is, but it's just something I had on hand because plastic wasn't going to be good enough. Wood wasn't working because the grain in one way would be fine, because say this way, but then this way it would break easily, or vice versa. So you have to use something solid, aluminum or steel or something. Something really. This is what I had on hand, so that's what I used. So that's the basic introduction of the machine. Let me hit the button and make it move for you. It's only running at about 80 inches a minute, 80 that is, and it'll run faster, but it runs reliably at 80, so that's where it's set. I've got about 7 inches of travel in the Z. Something, let's see, I've written it down somewhere. It's gone. What do I have? 16 inches, or maybe more than that. Seems like about, I don't know. Heck, I forgot. 20 inches by 25. Drawing a blank. Anyway, I got that much travel. I got a little bit more travel than what I'm using here. I mean, I did drill these holes with it. You can see I've got basically from here to here out, and I can go just a little further back. I can almost come out. I think I can come right out to here. If I wanted to, I could probably you know, you put something on the side here. I couldn't get too far out though. I didn't design it for that. I guess what I should have done if I wanted something like that is take this section here out, right here, and make some sort of a square plate, and I could put stuff in there and work on the side. But this is a purpose-built machine. It's for one specific product. If I ever quit doing that product, I'll just take this spoil board off, this fixture, and make something else. But yes, I do like it. And anyway, so this video series is going to be how I built it, why I made the decisions I did. Like I said, I designed it in Fusion 360. It's pretty nice, free CAD/CAM software. SolidWorks is good too. I hear. I think that's free. A lot of good stuff out there these days. So I'll talk about design aspect, and then I'll talk about different, you know, maybe pick apart each axis, X and then Y, then Z, and then get into the electronics. But it's a pretty basic system as far as all that goes. So there you go, the introduction. Thanks.